What if the size of Earth you carry in your head is completely wrong? Not just a little off one, but so distorted that if the universe could step far enough away and look back at our planet, it would barely find us in the frame. Tonight, you're going to gently test that idea. You're lying on one small patch of ground on a world that feels enormous when you have to cross a city or survive a week. But what happens when we put that feeling next to the universe's true scale? Welcome back, traveler. Tonight we drift through science. Imagine your room as a dim little capsule, soft light from your screen, the ceiling just above you, the faint breath of nighttime air. Somewhere beyond the walls, other people are falling asleep under the same sky. Before we begin, if this kind of calm science helps you exhale, you can tap like or subscribe. And when you're awake enough, tell me where on earth you're listening from and what time it is under your slice of night. Maybe you didn't come here just for curiosity. Maybe your mind has been spinning through a long day, replaying conversations, planning tomorrow, worrying about things that never feel quite finished. It's okay. You don't have to switch off your thoughts by force. You also don't have to understand every concept we'll touch tonight. This isn't an exam. If your attention drifts, if you miss a detail, if you fall asleep halfway through a sentence, that's not a failure. That's the script working exactly as it should. We'll wander slowly across different scales of reality. First, the Earth that fills your sky, then the solar system that makes it look smaller, then the galaxy that makes even the sun feel modest, then the cosmic web where planets disappear completely. Along the way, we'll stop beside the people and machines that figured this out. Telescopes staring from mountaintops and orbit, spacecraft turning their cameras back toward home, scientists wrestling with noisy data in quiet rooms late at night, trying to map a universe that won't fit on paper. Think of tonight less as a lecture and more as a long, slow walk in the dark with someone pointing out distant lights. There is no test at the end. You're allowed to close your eyes whenever you want. You're allowed to forget the numbers and keep only the feeling that Earth is far smaller than your instincts suggest, and that somehow that smallness can be comforting. If you'd like, you can dim your screen a little, adjust your pillow, let your body grow heavier, and follow me as we take the first small step away from your room and begin to see your world from the outside. You're still here, in the quiet of your room, feeling the familiar boundaries of your own little world, the edge of the mattress, the coolness of the pillowcase, the faint glow of your screen. If you stretch out an arm, you can touch the wall or the blanket. Beyond that, everything turns into guesswork and memory. From this position, Earth is an abstract word. What you actually feel is just a few meters of space wrapped gently around your body. Now imagine rising slowly, as if the ceiling softened and let you drift through it. You float above your building, above your street, above your city. Roads shrink into lines, cars into tiny moving dots. The patterns of your daily life compress. The route you walk, the places you sit, all become small folds in a much wider surface. You're seeing, for the first time tonight, how much room there already is just on this one tiny world. From a few kilometers up, the curvature of Earth begins to whisper its presence. The horizon stops being a flat edge and becomes a gentle arc. Clouds stretch into sweeping bands rather than isolated patches. If you could measure precisely, you'd find that the planet's radius is about 6,371 kilometers. That number looks modest on a page, but compared to your body, barely 2 meters long, it's enormous. You lying down are a microscopic scratch on the surface of a sphere. The first humans to really feel that spherical truth weren't astronauts, but explorers and navigators. Long before anyone left the atmosphere, people noticed ships disappearing hull first over the horizon, stars shifting with latitude, and Earth's shadow curving gently across the moon during eclipses. Later, surveyors measured angles between distant landmarks, and scientists like Eratosthenes estimated the planet's circumference using the length of shadows cast at different places. With simple tools and patient thought, they turned local observations into a global picture. You can imagine one of those early observers standing in a quiet courtyard at noon, watching the shadow of a pole crawl across the ground. Maybe it's hot and the air shimmers. They're not thinking of true scale yet. They're just writing down numbers. Only when those numbers are compared to someone else's, hundreds of kilometers away, does the curve of Earth reveal itself. Two small minds, far apart, collaborating to uncover the shape of the world under everyone's feet. Centuries later, satellites gave us our first real portraits of the planet. Weather satellites circling in low Earth orbit sent back grainy black and white images of swirling storms. Then came higher orbits, better cameras, richer colors. The famous blue marble photograph from Apollo 17 showed Earth as a full, illuminated disk against blackness. Oceans, clouds, continents, all visible at once. For the first time, ordinary people could see their home not as a flat map, but as a single glowing sphere hanging in space. In that image, there is no up or down, no preferred orientation. What looks like the top is just where the camera happened to be. Your country doesn't sit at the center. It's a shape along a curve. The borders that feel so solid in your daily life vanish completely. From that vantage, Earth is just a weathered ball of rock and water, wrapped in a thin, bright skin of air. Everything you've ever done fits somewhere on that fragile shell. Think again of your day. Messages sent, tasks done, worries carried from one hour to the next. On the scale of your room, they felt huge, maybe overwhelming. On the scale of that blue marble, they become tiny ripples in a thin band of habitability, hugging one planet's surface. The size of the Earth doesn't erase them. It just reminds you that your personal storms are local weather, not global cataclysms. They matter deeply to you, and that's enough. From the International Space Station, orbiting about 400 kilometers above Earth, astronauts circle the planet roughly every 90 minutes. They watch continents slide past beneath them, thunderstorms flashing like neurons firing, auroras draping the poles in shifting green and red. They can cross entire oceans in the time it takes you to watch a film. Inside the station, though, their lived space is small. Narrow corridors and sleep pods, a cup of coffee squeezed carefully from a pouch. Some astronauts talk about a change in perspective they feel up there, sometimes called the overview effect. Seeing the whole world at once, fragile, finite, borderless, alters the way they think about home. Conflicts that loom large on the surface shrink to invisible scars. The thinness of the atmosphere, the unity of land and sea, the sheer isolation of the planet in blackness, all of it sinks in. They return with the same bodies, the same lives, but a slightly different map inside their minds. You can borrow a little of that effect without leaving your bed. Picture Earth below you as a luminous sphere, clouds curling over blue oceans, night and day divided by a soft line of sunset. Somewhere on that sphere is your city, your street, your building. Your room is a dot on that dot. You can't see it from here. You can't see any buildings or people at all. You see only the whole, a single self-contained world turning slowly under your quiet breathing. Distances that feel huge down here, an hour's commute, a flight across a continent, become minor details on this scale. The longest drive you've ever taken would barely register as a pencil line across a globe. The tallest mountain you know, the deepest ocean trench, are small surface wrinkles compared to Earth's overall size. Even the airplane journeys that once gave you a sense of vastness are just small arcs in a thin layer of air. Geophysicists study what lies beneath that layer: crust, mantle, core. They listen to earthquakes with seismometers, watching how waves ripple through the planet's interior. From those ripples, they infer layers, densities, temperatures. No one has drilled more than a tiny fraction of the way down, but the data paints a picture of a hot, dynamic interior slowly moving, dragging continents along like rafts. Your room rests on a crust that is thinner, relative to Earth's size, than an eggshell on an egg. Think of a painted globe sitting on a desk. The layer of ink representing forests, cities, rivers, and oceans is vanishingly thin compared to the sphere beneath. If you scraped it off, the globe's shape would barely change. In the same way, the biosphere that feels like everything to you is a delicate coating on a much larger rock. Yet it's only in that coating that minds like yours appear, worrying about bills, wondering about galaxies, and listening to sleepy stories about scale. While you lie still, Earth keeps turning, carrying you eastward at hundreds of meters per second, depending on your latitude. You don't feel the motion because everything around you moves with you. Walls, air, bed, thoughts. Your body is locked to the planet by gravity, and your senses report stillness. But in a coordinate system centered on Earth, you're tracing a circle every 24 hours. In a system centered on the Sun, you're following a much larger loop along an orbit. For now, it's enough to hold two truths at once. On the scale that matters to your muscles and your nerves, your room is big, and Earth feels endless to cross. On the scale of the planet itself, you are tiny, your entire life smeared across a small patch of a spinning sphere. Neither view cancels the other. Instead, they fit together like layers. As you rest tonight, you're lying at the intersection of those layers, anchored to a world that is already large and about to start shrinking in your mind as we step outward to the next scale. You're still hovering in your mind above the bright curve of Earth when another shape glides into view, the Moon. At first it seems close, like the way you've seen it in photographs, just off to the side, a companion marble in the frame. But as you imagine pulling back a little more honestly, you realize how far apart they really are. Earth and Moon become two lonely spheres separated by a wide, dark gulf where you could fit all the world's worries and still have space left over. The Earth-Moon system is like a tiny two-body dance. Earth is about 4 times wider and far more massive, so the Moon orbits as a captured partner, bound by gravity. The distance between them averages about 384,000 kilometers. If you could drive there on a highway at normal car speeds without stopping, it would take several months. Light itself needs a little over a second to cross that gap. For radio signals and astronauts, it's a noticeable delay. During the Apollo era, spacecraft took about 3 days to travel from Earth orbit to lunar orbit. Mission planners plotted precise trajectories, taking into account gravitational tugs, fuel limits, and the timing of launch windows. Even now, when we measure the distance to the Moon, we're not guessing. Astronomers bounce laser pulses off reflectors left on the lunar surface by Apollo astronauts and Soviet landers, timing how long the light takes to return to the telescope on Earth's surface. You can picture someone in a quiet control room, watching a graph on a screen as faint blips line up. Each one a photon that left Earth, touched the Moon, and came back. From those travel times, they compute exact distances down to centimeters. 2 worlds, a laser pulse, and a stopwatch. The experiment is simple in concept, delicate in execution, and it turns an empty-looking stretch of space into something measured, known, and quietly mapped. From far enough away, though, even that measured distance becomes a small detail. Earth and Moon shrink into a paired bead, like a tiny imperfect pearl earring floating in black velvet. The thousands of kilometers you cross in an airplane, the minutes it takes to walk down your street, your sense of far and near, all of it folds into an almost invisible separation between these two spheres. Your everyday scale is already dissolving, and we've barely left the neighborhood. Now let your point of view drift farther until the sun begins to dominate the scene. Earth's blue fades into a pale dot, one of several specks circling a blinding star. Mercury, Venus, Earth, and Mars become faint grains close to the light. Beyond them, the giants, Jupiter and Saturn, Uranus and Neptune, trace wider, slower paths. You're no longer hovering over a planet. You're looking at an intricate clock of orbits, most of it empty space. Astronomers measure distances in this clock using the astronomical unit, or AU. The average distance from Earth to the Sun, about 150 million kilometers. On this scale, Earth sits at 1 AU, Mars at roughly 1.5 AU, Jupiter around 5 AU, Neptune near 30 AU. The numbers climb quickly. Light takes about 8 minutes to reach Earth from the Sun, more than 4 hours to reach Neptune, and still longer to reach any object at the fringes of the solar system. To understand how planets move in this vast arrangement, people once spent years tracking their positions against the stars. Tycho Brahe filled tables with meticulous observations. Johannes Kepler wrestled with those numbers until he realized planets trace ellipses, not perfect circles, around the Sun. Isaac Newton later showed how gravity and inertia combine to produce those paths. Centuries later, mission planners borrow those same equations to guide spacecraft from one orbit to another using brief carefully timed bursts of thrust. You can imagine those trajectories as narrow, invisible rails laid through the dark. Each one a path where a spacecraft can fall freely under gravity's pull. Engineers in windowless rooms write code and check models so that a probe launched from a small blue point will arrive years later, at another small point many AU away. Seen from outside, those journeys are tiny arcs hugging a star. Seen from within, they are some of the most ambitious steps your species has ever taken. Lying there, you might think of your own movements in comparison, the routes you take through your days, the circles you repeat, bed to kitchen, desk to door, city to city. On the scale of your life, those loops can feel exhausting, immense. On the scale of this orbital clock, they barely register. You are a pattern moving inside another pattern, a local rhythm carried along on a much larger one, Earth circling the Sun every year, almost indifferent to the dramas happening on its surface. Pull back again in your mind until the Sun itself starts to shrink. The bright disk becomes a small, intense point of light, surrounded by the faint jewelry of its planets. Beyond Neptune lies the Kuiper Belt, a region of icy bodies and dwarf planets. Farther still, in a hazy, roughly spherical shell, is the hypothetical Oort cloud, trillions of icy fragments loosely bound to the Sun, extending perhaps tens of thousands of AU. The solar system's true edge is fuzzy and far. Out there, space becomes incredibly empty. The average distance between objects in the Oort cloud may be measured in billions of kilometers. A single comet drifting through that realm is like a lone dust particle wandering the volume of a cathedral. When we say the solar system is huge, we're talking mostly about emptiness patterned by gravity. The worlds that feel so important, Earth included, are tiny islands scattered across a mostly silent sea. The farthest human-made objects, the Voyager 1 and Voyager 2 spacecraft, have been traveling outward since the late 1970s. Voyager 1 has crossed the boundary where the solar wind gives way to the interstellar medium, a region sometimes called interstellar space A, though the Sun's influence still lingers. It is more than 150 AU from the Sun now, so distant that radio signals traveling at light speed take over 20 hours to go one way between the spacecraft and Earth. In 1990, while it was still much closer in, mission controllers asked Voyager 1 to turn its camera back toward home. From about 6 billion kilometers away, it captured the famous pale blue dot image. In that photograph, Earth is a single, faint point of light, caught in a scattered ray of sunlight. No continents, no clouds, no cities, just a pixel, less than a pixel, containing every person, every story, every memory you've ever heard anything about. The decision to take that picture wasn't purely technical, it was philosophical, almost sentimental. The spacecraft had already completed its primary mission. The cameras were about to be shut off to save power. Someone suggested one last look back. Commands were sent. The craft slowly rotated, exposures were taken, and weeks later, the data arrived. On some screen, in some lab, a person scrolled through the noisy image and spotted a tiny mote of light. There, they realized, that's us. When you hold that image in your mind while lying here, Earth's smallness becomes impossible to ignore. Your entire day fits into that dot. Your plans, your fears, the things you said and didn't say, all of them live on a world that, from a few billion kilometers away, could be mistaken for a speck of dust on the lens. Instead of erasing meaning, this view often does the opposite. It invites a strange tenderness for the speck and for the lives piled onto it. Tonight, you've already watched your home shrink twice, first into a globe under your feet, then into a planet orbiting a star, then into a nearly invisible pixel in a family portrait taken from the darkness. The solar system, once a set of familiar textbook circles, has stretched into a mostly empty structure where distances are counted in light minutes and light hours. In the next quiet step, we'll move farther still, until even this whole arrangement becomes just one small feature in a much larger, star-filled landscape. For now, you can stay where you are, breathing steadily, while the sun and its planets keep turning without needing anything from you at all. You're still drifting out near the edge of the solar system in your imagination when the dark begins to thicken with pinpricks of light. The sun, which a minute ago felt like everything, has turned into just one bright star among many. If you let the solar system shrink behind you, the planets fall silent, the comets become invisible, and what remains is a vast, glowing city of stars stretching around you in a flattened, spiraling disk. This is your galaxy, the Milky Way. From inside, you never see it as a full spiral the way posters show it. You see it as a hazy band across the night sky, a milky river of light. Astronomers infer its shape from measurements and models: a barred spiral galaxy, a flattened disk about 100,000 light-years across, with several graceful arms curling outward from a central bar of stars and gas. You live somewhere along one of those arms. The numbers here are strange enough to feel fake. The Milky Way likely contains hundreds of billions of stars. Its disk is about 1,000 light-years thick in many regions, thin compared to its width, but unimaginably tall compared to your height. The Sun orbits the galactic center at roughly 220 kilometers per second, taking about 220 million years to complete a single loop. In all of human history, your star hasn't even made a full circuit. The rough structure of this galaxy was teased out over centuries by people counting stars and plotting their positions. Early astronomers like William and Caroline Herschel mapped star densities in different directions, guessing at the overall shape. Later, studies of variable stars and globular clusters showed that the true center lay far away in the direction of Sagittarius, not near the Sun. Radio observations of hydrogen gas traced out spiral arms, that optical telescopes couldn't see through dust. You can imagine those early observers in chilled domes or on open platforms, sweeping telescopes by hand across the sky, noting where stars crowded and where they thinned. Their local view was a narrow keyhole, but by comparing countless keyholes, a bigger picture emerged. What used to be a mysterious white smear became recognized as the inside view of a great disk. Your whole solar system turned into a suburb in a galaxy-sized city. Now picture yourself floating above that city, as if you could step a few thousand light years out of the plane of the disk and look back. Below you lies a glowing spiral, a bright central bulge surrounded by whorled arms, laced with dark dust lanes and bright knots of star formation. The region where the sun lives is about 2/3 of the way from the center to the edge, in a relatively quiet lane called the Orion Arm or local spur. Most of the stars you've ever seen with your naked eyes are within a few hundred light years of you. They are like porch lights in your immediate neighborhood. The rest of the galaxy, the hundreds of billions of more distant stars, is a soft background glow. If you tried to mark the sun's position on a detailed model of the Milky Way hanging in a museum, you'd need a pinhead smaller than a grain of sand. Earth at that scale would be far too small to draw. Modern missions like Gaia have turned this soft glow into a precise map. Gaia, orbiting around the sun near Earth, measures positions and motions of more than 1 billion stars with exquisite accuracy. Each star's tiny shift over time, its parallax and proper motion, reveals distance and velocity. Data scientists and astronomers transform these measurements into a 3-dimensional model of the Milky Way's disk, watching streams and clumps of stars move like currents in a glowing river. In radio and infrared wavelengths, other observatories trace cold gas and dust, the raw material for new stars. Together, these maps show that the galactic disk is not a static picture, but a dynamic, rippling structure. Spiral arms are regions where material piles up temporarily, like slow traffic zones on a highway. Stars drift in and out of them over millions of years. The neat symmetrical spirals you've seen are snapshots of a restless pattern. You, meanwhile, are lying on a bed that feels utterly still. Your heart beats in seconds, your thoughts flicker in milliseconds. The orbital period of your galaxy is so long that, in terms of star time, you are like a mayfly living and dying in the same patch of air before a single leaf finishes falling. Earth doesn't just shrink in space here, it shrinks in times too. Its entire recorded history squeezed into a fraction of 1 galactic year. Dark matter adds another invisible layer to this picture. When astronomers measure how fast stars orbit in the Milky Way, the outer parts move faster than expected if only visible matter were present. The rotation curve stays flat instead of dropping. The simplest explanation is a vast halo of unseen mass surrounding the galaxy, outweighing the luminous disk by several times. Earth, the sun, every star you can see, they all swim in this invisible gravitational ocean. To probe this unseen component, scientists combine data from stellar motions, gas clouds, and satellite galaxies. They run simulations where particles of dark matter and normal matter evolve under gravity, forming disks, bars, and halos. On screens, galaxies emerge as spinning coins of light embedded in diffuse, spherical clouds. The sun's orbit threads through this dark halo like a bead on a nearly invisible string. Again, Earth's true scale is reduced, a tiny fluctuation in the bright part of a much larger, mostly hidden structure. Metaphors strain to keep up here. You can think of the galaxy as a vast city seen from far above at night, its glowing streets and intersections tracing patterns of use and history. Your solar system would be one window in one apartment in one modest building in an ordinary district, Earth would be a room inside that apartment. Somehow, almost all of your sense of self and importance has been built in that one room, in that one building, in that one city. From an even greater distance, the Milky Way's bright disk would start to resemble the galaxies you've seen in Hubble images. A spiral with a bar, maybe a faint halo, one among many scattered through a deeper darkness. You're not quite ready to zoom that far yet, but you can feel the direction this is going. First the city of Earth, then the clockwork of the solar system, now the luminous coin of the galaxy. Each step has made your home feel smaller and more context-bound. And yet, as the scales grow, something else grows quietly alongside them. A sense of belonging to patterns far larger than your own story. You are not orbiting alone. The sun shares its path with countless other stars, all circling a common center, all sinking and rising gently through the plane of the disk like horses on a carousel. Your planet's smallness doesn't exile you. It roots you in a structure big enough to go on turning long after you've fallen asleep. As this thought settles, imagine the Milky Way slowly spinning in your mind's eye, a soft, luminous pinwheel woven from stars, gas, dust, and dark matter. Somewhere along one arm, too small to mark, a tiny world completes yet another turn around an ordinary star. On that world, in one small room, you're listening, breathing, and letting this grand structure exist without needing to manage it. In the next stretch of our journey, we'll let this entire galaxy join a crowd, and Earth will take yet another step toward invisibility. For now, you can simply drift with the disk, letting its slow rotation cradle you in thought. You're floating now above the whole disk of the Milky Way in your mind, watching its spiral arms turn like a slow, glowing pinwheel. For a long moment, it feels enormous, like this must be the final frame. Then, as you allow your viewpoint to drift farther back, other smudges of light start to appear around it. One, then another, then a faint cluster of them. Your home galaxy. Once the main character becomes just one swirl in a growing crowd. The nearest bright companion steps into focus. Andromeda, a spiral galaxy a little larger than the Milky Way, about 2.5 million light-years away. If the Milky Way were a glowing dinner plate, Andromeda would be another plate across a large room. Between them lies almost pure emptiness, no continuous star field, no luminous bridge, just the occasional faint dwarf galaxy and a thin haze of gas. Light takes millions of years to cross that quiet gap between neighbors. Together with dozens of smaller galaxies, the Milky Way and Andromeda form a modest island in space called the Local Group. You can imagine it as a scattered archipelago of star cities in a dark ocean. Some are grand spirals, others are faint, irregular smudges barely held together. Gravity binds them all in a slow dance. Over billions of years, their orbits weave an intricate pattern. One day, far in the future, the Milky Way and Andromeda will likely merge into a single, larger system. Human eyes first guessed at this structure by studying fuzzy patches in the sky called nebulae. Were they clouds within our galaxy, or island universes of their own? Early telescopes couldn't quite tell. It took better instruments and careful reasoning, like Edwin Hubble's work with variable stars in Andromeda, to show that some of these patches were far outside the Milky Way. In quiet observatories, people measured brightness and periods, discovering that what looked like small smears were entire distant galaxies. Now let your view keep expanding until the local group itself shrinks into a tiny knot of light. Around it, other knots appear, galaxy groups and richer clusters, each containing hundreds or thousands of galaxies. The Virgo cluster, tens of millions of light-years away, is one of the nearest large gatherings. On this scale, each galaxy becomes a fleck, each cluster a glimmering clump. The empty space between these clumps is vast, stretching for tens of millions of light-years at a time. Astronomers map these structures using redshift surveys. They collect light from millions of galaxies, spread it into spectra, and measure how much the light is stretched toward red wavelengths by the expansion of space. From those redshifts, they infer distances. Projects like the Sloan Digital Sky Survey have produced huge three-dimensional maps where each galaxy becomes a single dot. When you spin these maps on a screen, filaments and walls emerge, long chains of galaxies interconnected like threads in a web. From far enough out, the pattern looks eerily organic. Long strands of galaxies stretch across space, intersecting at dense nodes where clusters live. Between them yawn enormous voids, regions with very few galaxies at all. This is the cosmic web, a vast three-dimensional network of matter shaped by gravity over billions of years. Your entire galaxy is just one bead on one strand in this structure, and Earth is a microscopic speck buried deep inside that bead. Simulations help explain how this web formed. Cosmologists start with a nearly uniform early universe, seeded with tiny density fluctuations. Then let gravity, dark matter, and expanding space do their work. On their computers, those faint speckles grow into filaments and nodes over time. The resulting patterns closely match what surveys see. You can imagine researchers huddled around monitors in dim offices, watching universes bloom and comparing them to the one you inhabit, adjusting parameters until the models line up with reality. One of the most striking glimpses into this large-scale richness came from the Hubble Deep Field. Astronomers pointed the Hubble Space Telescope at a patch of sky that looked almost empty, smaller than a grain of sand held at arm's length, and let it stare there for days. When they combined the exposures, the image was packed with thousands of galaxies, spirals, ellipticals, irregulars, some so faint and far away that their light began the journey when Earth did not yet exist. That tiny patch is not special. If you could tile the entire sky with similar deep fields, you'd find similar crowds almost everywhere. Your sense of a sparse, isolated universe comes from how limited your eyes are, not from how populated space actually is at these scales. The nights that feel so empty above your home are, in truth, full of structures you can't see without the right instruments and the patience to collect very old, very faint light. Behind each of those deep images lie years of careful human labor. Engineers designed mirrors, instruments, and guidance systems. Astronauts flew to Hubble to repair and upgrade it when its optics were flawed or its hardware aged. Scientists wrote proposals, checked calibrations, processed noisy data, and argued over faint smudges in pixels. The quiet beauty of the deep field is a collaboration between the universe's tendency to structure itself and humans' determination to notice that structure. As you drift even farther back in your imagination, individual filaments and clusters blur into a nearly uniform glow. On the very largest scales, the universe looks statistically the same in every direction and from every typical place. This is what cosmologists call homogeneity and isotropy. Tiny variations exist, but the broad brushstrokes are smooth. There is no central point marked "you are here." There is no special vantage. The cosmic web repeats its patterns everywhere you look. On this level, Earth has vanished completely, not just as a pixel, but as anything you could meaningfully mark. Your entire observable universe becomes a roughly spherical volume centered on you, defined not by physical edges, but by how far light has had time to travel since the Big Bang. Somewhere inside that sphere sits the Milky Way. Inside that, the Sun. Around the Sun, a thin shell where a small rocky planet quietly hosts your particular evening. Knowing this can feel disorienting. Your instincts like edges and centers. They want a top and a bottom, a middle you can point to. The universe refuses that simplicity. It offers instead a repeating, large-scale sameness where no galaxy, cluster, or filament is truly central. True scale, in this sense, means accepting that your home is not perched at the hub of anything. It is tucked away in an ordinary corner of an ordinary strand in a widely woven web. Yet, ordinary here doesn't mean worthless. It means that the laws of physics don't treat your location as special. Gravity pulls, light travels, matter clumps, just as it does elsewhere. The fact that, in one small zone of that web, chemistry has become biology and biology has become awareness is not written into the large-scale map, but it's real on the scale where you live. You are a local exception in a non-local pattern, a pocket of experience inside a broad, unfeeling regularity. As this picture settles, you might feel that your worries today are shrinking again, one more step down in importance compared to filaments and clusters. Let them. On the scale of the cosmic web, your anxious thoughts are fluctuations smaller than dust. That doesn't make them fake. It just means they belong to a very small layer in a very layered reality. In the next gentle turn of this journey, we'll shift from these grand structures to the rules that stretch them, expansion, light, and time, and see how they twist your sense of what here and now even mean. For now, you can simply rest inside the knowledge that your entire life plays out in a tiny knot of light on an immense patient web, and that it's perfectly all right to let that web spin on without you solving any of it tonight. You're lying in your room, and by now your sense of out there has stretched so far that it almost stops meaning anything. You've seen Earth dissolve into the solar system, the galaxy, the cosmic web. But there's another trick the universe plays with scale that you can't see, only infer. The way light moves, slowly but surely, through all of this. You never see the universe as it is now. You see a collage of different times stitched together by finite light. Think about the night sky again, the one above your ceiling. Every star is a delayed message. Light from the moon is just over a second old. From the sun, about 8 minutes. From bright nearby stars, decades. From distant galaxies, hundreds of millions or even billions of years. There is no single present moment out there. When you look up, you're peeking into a stack of old photographs, all pinned to the same black wall. Astronomers lean on this delay to turn distance into time. The speed of light, about 300,000 kilometers per second, is fast on human scales, but sluggish on cosmic ones. They talk about light years. The distance light travels in a year, about 10 trillion kilometers. A star 10 light years away shows you a 10-year-old portrait. A galaxy 10 billion light years away shows you the universe when it was young. The farther you look, the further back in history you're forced to see. To measure these distances, scientists spread starlight into spectra, tiny rainbows. Dark lines in those rainbows correspond to specific atoms absorbing certain colors. In faraway galaxies, those lines appear shifted toward red wavelengths, red-shifted, because the space the light crossed has stretched during its journey. The amount of shift encodes how much the universe has expanded while the light was en route. In quiet offices, people fit curves to these lines, turning faint wiggles into measurements of time and distance. You can imagine each photon as a small traveler that left home when the universe was younger, carrying a bit of color information like a stamped passport. By the time it reaches a telescope mirror or a digital sensor, billions of years have passed. The universe has grown, cooled, and changed. All you see is the photon's arrival. The rest, the long, silent crossing, is invisible, but it's where the meaning of scale truly bends out of everyday shape. Now picture a three-dimensional grid painted on space, lines extending everywhere. On small scales, your room, your city, even the distance to the sun, that grid feels rigid. Distances don't change, but on the scale of galaxies, the grid itself stretches. Space expands, slowly, like elastic. Galaxies are mostly not flying through space like shrapnel. They're more like pins stuck in a soft balloon that's being gently inflated. The pins move apart because the material between them grows. This behavior showed up first in the relationship between redshift and distance. Astronomers like Edwin Hubble noticed that, on average, more distant galaxies have higher redshifts, as if they're receding faster. The simplest explanation is that the scale of the universe is increasing with time. Double the distance, roughly double the recession speed. On very large separations, this apparent speed exceeds the speed of light, not because galaxies are breaking rules, but because the stage beneath them is stretching. To test and refine this picture, teams used standard candles like Type Ia supernova, stellar explosions with fairly consistent intrinsic brightness. By comparing how bright they ought to be with how faint they appear, they estimate distance. Combined with redshift, those measurements reveal not just that the universe is expanding, but that the expansion is accelerating, as if some mysterious pressure, dark energy, is gently but persistently pushing the grid outward, making faraway galaxies slide away ever faster. All of this plays havoc with your intuition about size. When you hear that the observable universe is about 93 billion light-years across, you might imagine light traveling that far in 13.8 billion years and feel a mismatch. The resolution is that while the light was in transit, the grid stretched. What started as a smaller separation grew along the way. You're seeing distant galaxies as they were long ago, but measuring how far away they are now in an ever-expanding fabric. A helpful way to picture it is to surround yourself with invisible shells. The closest shell holds objects whose light is almost up to date: the moon, the sun, nearby stars. Further shells represent zones whose light left earlier and earlier in cosmic history. The outermost shell is defined not by walls, but by time. Beyond a certain distance, light simply hasn't had long enough since the Big Bang to reach you at all. That boundary is your cosmic horizon. At that horizon sits a relic from the universe's youth, the cosmic microwave background. About 380,000 years after the Big Bang, the universe cooled enough for atoms to form and for light to travel freely. The glow from that moment still surrounds you, stretched into microwaves by billions of years of expansion. Satellites like COBE, WMAP, and Planck mapped this faint, nearly uniform radiation, measuring temperature variations of only millionths of a degree spread across the entire sky. Behind those maps were years of engineering and analysis. Instruments were cooled to cryogenic temperatures so their own heat wouldn't overwhelm the signal. Satellites spun slowly, scanning the sky. Data streams filled with noise, galactic emission, instrument quirks, stray signals, had to be cleaned carefully. In shared offices and late-night shifts, scientists subtracted foregrounds, cross-checked calibrations, and gradually revealed a speckled pattern, tiny hot and cold spots, the seeds of all the later cosmic structure. Those tiny fluctuations show you that the universe was once astonishingly smooth. On large scales, matter and radiation differed in density by tiny fractions. Gravity amplified those small differences over billions of years into galaxies, clusters, and the web you imagined earlier. When you hold the image of the microwave background in your mind, you're looking at a baby picture of everything, taken long before Earth, before the Sun, before any planet had solid ground to stand on. Place Earth on this unfolding timeline, and its true temporal scale shrinks again. The universe is about 13.8 billion years old. Earth formed around 4.5 billion years ago. Complex multicellular life is younger still. Your species has existed for a blink. Your individual life occupies a sliver at the end of that blink, thinner than a scratch on a long ruler. On a diagram, you'd have to exaggerate your lifetime enormously just to draw it at all. And yet, from your perspective, your lifetime feels like the full length of time itself. The years behind you feel dense with experience. The years ahead feel significant enough to worry about. The cosmos doesn't share that feeling. It ticks along according to expansion, gravity, and nuclear reactions in stars. It doesn't notice when someone on a small planet stays awake thinking about horizons and redshifts. The meaning in your years comes from inside your limited frame, not from their size. As you lie there, you inhabit a tiny region in both space and time, a small area on a small world during a brief temperate chapter in that world's history. You breathe air that hasn't always been here, and won't always be here. You worry about tomorrows inside a universe where tomorrow is not a meaningful unit. Somehow, this mismatch doesn't make your concerns fake. It just means they belong to a very local kind of scale, the human kind. Let that be enough for now. The universe will continue to expand. Shells of visibility will continue to grow. New light from distant events will keep arriving long after you're gone. You don't have to ride that whole wave. Tonight, it's enough to know that Earth's true size is not just small in distance, but brief in time, and that your life is briefer still, and that this brevity can be a reason for gentleness rather than panic. In the next quiet turn, we'll bring the focus back from these grand horizons toward the thin, fragile layer on Earth, where all of your actual moments happen, and see how small the stage of life really is compared to the planet that hosts it. You're lying there with all these numbers drifting through your mind, and at some point you probably bump into a quiet frustration. You've never actually seen a truly honest picture of all this. Every diagram you've met, posters of the solar system, spirals of the Milky Way, grids of galaxies, was a compromise. They're designed not to be faithful, but to be teachable. Your brain, tuned for rooms and trees, demands shortcuts. Artists oblige by cheating distances and inflating objects until the lie feels like truth. Take the classic classroom solar system. The sun, a bright circle, the planets lined up neatly, each orbit a tidy ring not much larger than the last. It's a friendly map, but wildly inaccurate. If the sun on the page were scaled correctly to the planets, they'd be microscopic dots, and the outer ones would need to be drawn meters away. A truly honest poster of the solar system would be mostly blank paper with a tiny cluster of ink near the center. People have tried to fix this by building physical scale models over long distances, a big sphere for the sun in one park, then tiny marbles for planets scattered along a beach or a road, sometimes kilometers apart. Participants walk for long minutes between worlds. When they finally reach the outer planets, they often say the same thing. I never realized how much nothing there is. The planets themselves feel like afterthoughts hung on the vastness of their own emptiness. To make stars and galaxies share the same page with atoms and cells. Scientists often use logarithmic scales. Each step on the axis represents a multiplication instead of a simple addition. Meters, micrometers, nanometers, light years, stacked in tidy increments. Graphs like that can place the radius of a proton and the size of the observable universe on one continuous line. But the trade-off is weirdness. Equal-looking intervals no longer correspond to equal physical jumps. Your intuition mutters that the ruler is cheating. Visual projects like Powers of 10 and its many descendants try a different route. They show you a zoom-out journey frame by frame. A hand, a picnic, a city, then Earth, then the solar system, then the galaxy. Each step jumps by a factor of 10 in scale. Watched as a film, the transitions feel smooth. Your brain doesn't have time to panic. But if you pause on any single frame and stare, the numbers printed in the corner begin to feel almost comically abstract. Behind those images are teams carefully choosing what to exaggerate and what to suppress. If they kept the true brightness contrast between stars and galaxies, everything but a few points would vanish into black. If they kept the true relative sizes, you'd lose track of the smaller objects completely. So they bend reality, brighten faint things, enlarge tiny ones, shrink enormous ones. It's honest in spirit, but not in proportion. The goal isn't accuracy, it's understanding. Astronomers do a similar kind of bending in their public imagery. Raw telescope data often looks underwhelming, dim, grayish, speckled with noise. To reveal structure, they stretch contrast, assign colors to different wavelengths, and combine multiple exposures. The result is stunning. Nebulae blaze with false color filaments. Galaxies glow in blues and golds. These views are faithful to the physics in some ways, and wildly misleading in others. Beauty and clarity take precedence over a strict representation of how your eyes would see it. Even maps of the cosmic microwave background, those speckled blue and red ovals, are, in a sense, lies told for a good reason. The temperature variations are amplified thousands of times so you can see the pattern. If shown at true intensity, the image would look nearly uniform. The baby picture of the universe is, fundamentally, very smooth. The lumps that later became galaxies are slight smudges on an almost even canvas. Only by exaggerating them do we even notice they exist. If someone tried to draw a perfectly scaled image of the observable universe with Earth marked on it, they'd run into a wall fast. To fit everything on a page, they'd have to make the universe so small that the dot representing Earth would be much tinier than a speck of dust. Too small to print, too small to see. If they insisted on drawing Earth as a visible point, the universe around it would have to be shrunk into nonsense. There's no middle ground that satisfies both, so your mental pictures are always stitched together from compromises. A bit of honesty here, a bit of distortion there. A galaxy blown up so you can admire its arms, a planet inflated so you can see its color, distances crushed so systems fit onto screens. None of this is wrong. In fact, it's necessary. The alternative would be staring at mostly empty black rectangles with a few barely perceptible specks and being told, "Trust me, this contains everything." Your brain handles this barrage of mismatched images with a quiet trick. Beyond a certain point, everything very large gets dumped into the same mental category. Huge, a mountain, a planet, a galaxy, a cluster. They all feel more similar than they actually are. Once that happens, Earth stops shrinking in your inner picture because there's no larger bucket left to compare it to. True scale gets flattened into a ladder with only a few rungs: UCO, your world, and all the rest. Scientists, artists, and educators live with this limitation every day. They know that no single diagram can hold all the ratios honestly. So they build constellations of partial truths, one graphic for distances, one for sizes, one for timescales, one for brightness. Each tells you something real while hiding something else. To understand even a slice of true scale, you weave these partial maps together in your mind, letting them overlap and contradict until a more nuanced feeling emerges. Lying there, you might notice that what really stays with you from these attempts isn't the exact numbers but a mood, the sense that everything beyond a certain point is overwhelmingly sparse, overwhelmingly large, and strangely gentle in its indifference. You can't picture 10 trillion kilometers any more than you can picture a billion years. You can only feel that your usual sense of size and duration is out of its depth. That feeling is not a failure, it's honesty. So when you hear that Earth is small or that the universe is vast, it's okay to admit that you don't see it clearly in your head. Nobody does, not even the people who work with these numbers every day. What they have instead is a cultivated respect for their own ignorance, a habit of treating the diagrams as useful lies, and the real ratios as something to approach sideways, with humility, storytelling, and a lot of patience. As your eyes grow heavier, you can let go of the pressure to form one perfect mental picture where every scale fits. It's enough to know why your maps will always be off, because the ratios are so extreme that any honest drawing would look like nothing. The universe, drawn to scale, would leave almost no trace of you on the page. And yet, that same universe has produced a mind that can notice this, feel a little dizziness, and then, slowly, find calm in the admission that some things are simply too large to see clearly from a bed on a tiny world. You're still in the dark of your room, watching these giant structures drift past in your thoughts, when another kind of question quietly appears. If Earth is this small, and you are smaller still, what does that make your life worth? You can feel your body, the weight of it on the mattress, the familiar pulse in your chest. Out there, galaxies collide in slow, silent arcs. In here, a single bad day can feel bigger than anything the cosmos has ever done. From the universe's point of view, if it had one, Earth is just a particular arrangement of atoms, no more inherently important than a distant cloud of gas. But from your point of view, it's everything. Every memory you have is painted onto scenes within a few kilometers of this surface. Every person you care about is bound to this one small world. Even your imagination of other planets is built entirely from colors, textures, and emotions you first learned here. There's a quiet bias baked into that situation. You only get to ask questions about scale from places where a brain like yours can exist. If the constants of physics were slightly different, stars might never form, or burn too quickly for planets to cool, or never forge the heavier elements that make rocks, oceans, and bodies possible. Most imaginable universes would be empty of thinkers. You occupy the rare sort of universe where conditions accidentally line up to allow wondering. Physicists sometimes explore this with models, tweaking parameters in equations to see what kind of cosmos emerges, change gravity's strength or the masses of particles, and their simulated universes collapse too fast or remain too diffuse. Only in a narrow range of settings do galaxies condense, stars live long enough, and chemistry becomes rich. Looking at those models, researchers don't usually say this proves meaning. They say something more modest. Of course, we find ourselves in a corner where life is possible. Within that already narrow corner, the path to Earth gets narrower still. A stable star of the right type, a planet at the right distance for liquid water, a rocky surface, and an atmosphere that remain, more or less, within a livable band for billions of years. A chain of chemistry that stumbles, slowly, into cells, and then into nervous systems capable of experience. From a distance, it all looks like a generic speck. Up close, it's a wildly specific accident. You can imagine alternate versions of this world that never produced beings like you. Maybe the planet froze over completely and never thawed. Maybe it stayed too hot, or its atmosphere blew away. Maybe life arose but never got past simple layers of slime in shallow seas. The difference between those timelines and yours is encoded in tiny contingencies, small swings in climate, asteroid impacts that did or didn't happen, little genetic mutations that succeeded or failed. Researchers in evolutionary biology and planetary science spend their careers probing these contingencies. They study fossils, simulate climates, and examine exoplanets for hints of habitability. In observatories and labs, they measure the spectra of distant atmospheres, searching for oxygen, methane, or other possible biosignatures. In notebooks and conferences, they debate how likely it is for life to appear and for intelligence to arise if it does. The honest answer, so far, is that nobody knows. The sample size, one planet, is too small. That uncertainty cuts both ways. On one hand, it's possible that the universe is teeming with life and minds, spread across billions of worlds, most too far away for you ever to meet. On the other, it's conceivable that Earth hosts the only conversation like this anywhere right now. The data you have today can't tell you which is true. All you know for sure is that, in your observable patch, only one small blue world has confirmed awareness. From a numerical standpoint, that awareness is almost invisible. The total mass of all humans is negligible compared to Earth's mass, and Earth's mass is negligible compared to the Sun's, and so on up the chain. If you plotted amount of matter that can think versus amount that can't, the thinking part would be a thin line hugging the bottom of the graph. But that thin line is where all the stories are, all the fears, all the hopes, including yours tonight. It might help to think of the universe as having more than one kind of scale. There's physical scale, distances, masses, energies. On that axis, you and your planet sit near the bottom. But there's also experiential scale. How much a given event can feel like anything to anyone. A supernova on the far side of the galaxy is spectacular in energy and almost zero in experience. A single honest conversation, or a moment of relief as you finally relax, is the reverse. Psychologists and neuroscientists study that experiential side in modest rooms with fluorescent lights, far removed from telescopes and particle accelerators. They scan brains, measure heart rates, and ask people how they feel. They watch how attention narrows under stress and widens in safety, how small acts of kindness shift entire inner landscapes. None of these experiments change the universe's size, but they reveal just how much richness can fit into very small pockets of space-time, like the one you occupy right now. Seen this way, your physical smallness stops being an insult and becomes more of a design decision. If you had to carry the emotional state of entire galaxies, you would be crushed instantly. Instead, you get a tiny window, a handful of relationships, a finite number of days, a room-sized field of direct sensory experience. Inside that window, things can matter deeply without needing to be large. Outside it, the universe is allowed to remain mostly neutral background. As you feel your body growing heavier against the bed, you can let this double perspective settle. On the map of physical scale, you're a microscopic ripple on a small world in a typical galaxy. On the map of lived reality, You are the center of your own universe, the only place where your particular blend of memories and feelings exists. Neither map is wrong. They just answer different questions. One asks, how big? The other asks, what is it like to be here? Tonight, you've spent a long time with the first map, letting how big stretch far beyond your comfort zone. Now, slowly, you can lean toward the second. Instead of asking whether you matter to galaxies, you can ask whether you matter to the small circle of lives that actually touch yours, and whether you're willing to treat yourself with the same gentleness you'd naturally offer to any other tiny, temporary being trying to make sense of a giant kind's indifferent backdrop. In that light, Earth's smallness stops demanding a grand answer from you. It becomes the stage on which an ordinary, fragile, meaningful enough life can play out. The universe doesn't need you to be anything other than local. Your job is not to fill all of space and time with significance. It's to inhabit your narrow slice with as much honesty and kindness as you can manage. One evening, one breath, one tiny planet at a time. You're lying there in the dark, and it's tempting to think of time as the stretch between a few birthdays, a handful of New Year's fireworks, the memories you can still feel in your body, your calendar app, your old photos, your scars and routines. That's what a long time means from where you're resting. But the ground beneath you is older than any of that by a margin your instincts can't really hold, no matter how many zeros you add. Imagine squeezing Earth's entire 4.5 billion year history into a single calendar year. On that scale, each day is about 12 million years. The planet forms in early January, a molten sphere hammered by impacts. Oceans condense in March. Simple life appears sometime in the spring. For most of that year, the world is a microbial planet. No trees, no flowers, no animals, just cells slowly learning new tricks. The scenery above them changes, but very, very slowly. Complex multicellular life doesn't arrive until late November. Dinosaurs show up around December 13th. They dominate for weeks, roaming through forests and swamps while continents drift. They vanish on December 26th when an asteroid hits. Mammals, once small and timid, start to radiate. On this scale, humans like you appear in the last minutes of December 31st. Everything you'd call history, cities, writing, science, fits into the final seconds before midnight, a thin scratch at the end. Geologists piece together this story using clues that, at first glance, don't look like clocks at all. Radioactive isotopes decay at steady rates, so the ratios inside crystals reveal ages. Layers of sediment stack one on top of another, encoding sequences of environments. Fossils capture the shapes of creatures long gone. In labs and field camps, people compare rock cores, measure isotope ratios, argue over ambiguous traces. The result is a timeline that dwarfs any human lifespan. You can think of Earth's history as a thick book where most pages are filled with slow, almost repetitive handwriting, and the last sliver is dense with tiny, frantic script. Your personal story is a single sentence in that last sliver. This isn't an insult, it's just the scale. The melancholy that creeps in comes from realizing how little of the book you'll ever read, and how quickly your own line will fade compared to the pages already turned. Now imagine walking along a beach that somehow runs parallel to deep time. Each step you take carries you millions of years forward or backward. At one stretch, the air is thin and harsh, the land barren. Further along, strange forests tower overhead, filled with ferns and giant insects. At another section, ice presses toward the equator, turning most of the world into a glistening, frozen desert. The shoreline looks familiar, waves of wind, but the world wearing it is alien. Evidence for these past worlds hides in rock chemistry and ancient landscapes frozen in place. Snowball Earth episodes leave glacial deposits at latitudes that should be warm. Warm hothouse eras show up as fossil coral reefs near poles and chemical signatures of high carbon dioxide. Cores pulled from ocean floors reveal shifts in microfossils and sediments. Each drill, each core, each lab analysis becomes another window into a planet that repeatedly reinvented itself long before you arrived. When you stand at a modern shoreline, listening to the surf, you're occupying just one of those reinventions. This coast, these climates, these familiar animals, they are one set of props in a theater that has hosted many plays. Entire casts, trilobites, ammonites, dinosaurs, had long, complex histories and then exited completely. Your era feels permanent only because you've never known another one. On the geologic clock, it's more like a brief scene between longer acts. Walk that imaginary beach forward, and the changes don't stop with today. The sun will continue to brighten as it ages on the main sequence. Over the next hundreds of millions of years, increasing solar energy will gradually push Earth's climate toward a hotter state. Oceans will evaporate more quickly, water vapor will amplify warming, and the temperate band your body relies on will begin to fray. The cozy conditions you call normal are temporary, not guaranteed. Stellar models, tested against observations of other stars, map this future with sobering detail. The Sun is about 4.6 billion years old, roughly halfway through its stable hydrogen-burning phase. In perhaps a billion years or so, Earth's surface may become too hot for liquid water oceans to survive. Later, in several billion years, the Sun will swell into a red giant, shedding its outer layers, possibly engulfing the inner planets, and eventually leaving behind a dense white dwarf ember. Astronomers don't have to guess blindly about this fate. They observe stars like the Sun at different ages, watch red giants puff off gas, and study white dwarfs cooling in star clusters. Some white dwarfs show signatures of heavy elements in their atmospheres, clues that planetary debris is falling onto them. Telescopes catch dusty rings and disrupted asteroids around aging stars, snapshots of planetary systems being dismantled. Those scenes are previews of chapters Earth hasn't reached yet. Seen from this angle, Earth's habitable lifetime is a narrow window, a few billion years where things are neither too hot nor too cold, neither too chaotic nor too barren. Your own life spans only a flicker at the tail end of that window, and even within that, you only remember a fraction. The finite nature of it all, the planet, the species, the individual, can feel like a soft weight pressing against your chest while you stare at the ceiling in the dark. But you can also hear it as a quiet kind of honesty. The world beneath you is not a static pedestal built forever just to host your worries. It is a small evolving place with a beginning and an end, and you happen to exist during one of the brief chapters when oceans still move, air still breathes, and nights like this are possible at all. The smallness in time is another way of saying, this won't last, so this matters. Your personal timeline sits nested inside all these larger ones. Human history inside the age of mammals, mammals inside the age of complex life, life inside Earth's story, Earth inside the universe's unfolding. From above, the nesting looks like a set of shrinking circles, each barely visible against the one outside it. From within, your own circle feels like the only one that is fully colored in. The tension between those two views is where the melancholy lives. As your thoughts slow, you can let both views coexist without forcing a resolution. Yes, Earth is small in space and brief in cosmic time. Yes, your life is smaller and briefer still. And yet, within your limited span, you still get to stand on a world that is currently alive, currently lit by a steady star, currently offering breathable air and liquid water, and nights safe enough to lie down and ponder any of this. That's not everything, but it's also not nothing. In the quiet that follows, the deep time behind and ahead of you doesn't require action. You are not responsible for rescuing the planet from its eventual red giant fate, or for redeeming billions of years of history with a single life. Your role is humbler and kinder, to inhabit your tiny slice of this finite world as fully and gently as you can. In the next stretch, we'll move even closer to your own scale, your days, your memories, your relationships, and see how all this vast, indifferent context can actually make your small human timeline feel a little softer, not colder. You're still stretched out in the dark, and now the vastness you've been visiting starts folding back toward you in a quieter way. Not as galaxies and clusters, but as a simple, strange fact. Even on this tiny world, you will only ever touch a very small patch. Earth's surface covers about 510 million square kilometers. Your whole life will trace over a few thousand at most. Thin streaks of movement on a sphere you mostly know through screens and stories. Imagine rising again above your city, then your country, until political borders disappear and the planet looks like swirling weather and textured land. Under those clouds are deserts you'll never feel the heat of, forests you'll never smell, languages you'll never hear in person. Satellites in low Earth orbit see it all, passing over every point on the surface every few days. You, down here in one room, get a handful of coordinates that become home. Those satellites didn't appear by accident. Engineers designed and launched them, calculating orbits and fuel, building cameras and radios that can survive radiation and vacuum. Ground teams receive their data as streams of numbers, latitude, longitude, brightness, temperature, and turn it into the maps you pinch and swipe on your phone. Your idea of Earth's size is filtered through those choices: which images to color, which roads to draw, which details to label, which to leave blank. From above, though, the map never shows you what it feels like to stand in a specific doorway, or to lie in a specific bed after a difficult week. The resolution that matters most to you is not in meters per pixel, but in memories per place. One street corner might hold an entire chapter of your life. An entire continent might exist only as a vague outline in your mind. The physical size of Earth and the emotional size of Earth rarely match. Now zoom back down to the scale of people. More than 100 billion humans are thought to have lived and died on this planet since our species emerged. The vast majority left no written record. Their thoughts, jokes, fears, and small acts of courage are gone, absorbed back into the quiet statistics of population curves. A few left inscriptions, tools, bones. Archaeologists kneel in dust, brush off fragments, and try to reconstruct whole lives from a broken pot or a burial site. In museums and books, those reconstructions turn into tidy labels: Neolithic farmer, Bronze Age trader, Roman soldier, entire lifetimes compressed into 2 or 3 words. The richness that filled those days, the specific smell of their fires, the cadence of their conversations, the particular way their worries felt in their chests, is absent. Earth has hosted oceans of inner worlds as vivid as yours, and the planet remembers them only as faint chemical and structural traces. Historians sift written records and diaries, trying to add more detail. They quote letters, analyze laws, trace family lines. Even then, they only manage to spotlight a tiny minority of people. Most humans remain anonymous, their existence known only as numbers in census records, if that. From far enough away, human history looks like a smooth curve. Up close, it's made of discrete, brief lives like yours, each one the center of its own universe for a little while. If you've ever felt pressure to leave a mark big enough to survive centuries, this perspective can sting. It whispers that statistically your name will fade, your digital traces will erode, your struggles will not be footnotes in any grand chronicle. But it can also be strangely liberating. If even empires blur together at galaxy scale, maybe the point was never to be permanently visible. Maybe the point is to be honestly present during your very short segment of the curve. Bring the scale down further, to a single day. You wake, move through routines, think thousands of stray thoughts, feel dozens of emotional micro-weather changes. By evening, only a few of those will be vivid. By next week, fewer still. Neuroscientists who study memory talk about consolidation, how the brain replays and edits experiences during rest, deciding which to stabilize and which to let dissolve. Sleep isn't a pause in life. It's part of how life decides what to keep. In lab experiments, volunteers learn simple tasks or word lists, then either rest or stay awake. Later tests show that those who slept often remember better, even if they weren't trying. Brain scans reveal patterns reactivating during certain sleep stages, as if the mind is quietly rehearsing or reorganizing. While you're off in dreams you may not recall, your nervous system is curating the museum of what mattered from the day that just ended. Viewed from the outside, this curation is tiny. Electric activity in 1.5 kilograms of tissue inside a skull on a small planet. On the inside, it decides which moments continue to exist for you at all. A fleeting kind gesture might be replayed and strengthened. A part of a rough conversation might be softened or blurred. Your sense of who you are and what your life has been is built from this selective sampling, not from the full raw footage. That means your internal Earth is even smaller than the physical one. It consists of the places and times your mind has chosen, consciously or not, to revisit. A childhood room might loom larger in your inner geography than entire countries you've flown over. A single night, good or bad, can stretch in memory far beyond its real 8 or 9 hours. Compared to the planet's crust, the territory you truly inhabit is a handful of rooms and stretches of road. On some nights, the mismatch between these scales can feel heavy. You might lie there thinking about all the paths you didn't take, all the places you'll never see, all the alternate lives you'll never live. Each unrealized option can feel like a small grief. Multiplied by years, they become a quiet background ache, an awareness that your version of existence occupies a very narrow corridor in the maze of what could have been. But remember what you've seen on larger scales. Even the universe itself never explores all its possibilities. Most regions of space remain empty. Most combinations of matter never form. Structures emerge where conditions happen to allow them, then fade. Your life is not a failure for being narrow. It's following the same pattern everything follows. A small patch of possibility lights up for a while, then goes dark. The lights don't need to cover every corner to be real. As your eyes grow heavier, you can treat this realization less like a verdict and more like weather passing through. Yes, you will only touch a tiny fraction of your planet in a tiny fraction of its time. Yes, most of what you are will leave no lasting mark at the scales that star charts care about. And still, right now, you get to breathe, to listen, to let your own inner Earth be enough for tonight. This room, this body, this small stretch of consciousness held briefly on a very small world. You're still here, in the same bed, on the same floor of the same small world. After all the zooming out, the most radical move now is to stay put and notice how many layers of reality pass quietly through your body at once. Gravity holds you to the mattress. Air presses gently against your skin. Electrical signals fire in your brain. Somewhere far above the roof, satellites arc overhead. Far beyond them, galaxies slide along the cosmic web. You are touching all of these scales without moving at all. If you wrote your full cosmic address, it would start tiny and grow absurd. Room, building, street, city, country. Then, Earth, third planet from the Sun, in a system about 30,000 light years from the center of the Milky Way. That galaxy sits in the local group, near the Virgo cluster, within the Laniakea supercluster, inside the observable universe about 93 billion light-years across. The fact that you can even say this from a bed is its own quiet strangeness. Scientists piece this address together using many tools at once. Seismometers for Earth's interior, rockets and radars for near space, telescopes for stars and galaxies, satellites for the cosmic microwave background. No single experiment reveals the whole thing. It's a mosaic of measurements and models. In offices and observatories scattered across your small planet, people compare notes, adjust equations, and gradually refine the picture of where you are in everything. You can imagine those people as tiny glimmers on the dark side of Earth, working late under desk lamps, sipping coffee gone cold while code runs or data plots slowly refresh. Outside their windows, the same star field you've been picturing stretches over their cities. They may never meet you, but their work is part of what allows you to lie here and hold the idea of a true scale at all. It's a chain of curiosity linking strangers across continents. Zoom back in to the scale of your brain. Roughly 100 billion neurons, each making thousands of connections, constantly exchanging tiny electrical impulses. When you feel awe or calm, it's because certain networks, ones linked to self-focused rumination, quiet down, while others that process sensory richness and connection light up. Researchers see this in scanners. When people contemplate vastness, their sense of being a separate, isolated I often softens for a while. Psychologists studying awe have found that moments of vastness mixed with safety can make people feel both smaller and more connected. Participants who look at huge natural landscapes or starry skies often report less obsession with their own problems afterward, and measures of stress or inflammation sometimes dip. In controlled settings, photos on screens, short videos, the effect is modest but real. You tonight have been running your own private extended version of that experiment in your imagination. Think of awe as a gentle lens that changes how sharp your worries feel, but not whether your life matters. It doesn't erase your responsibilities or your pain. It just places them against a backdrop where they're not the only things that exist. Like seeing your house on a map of the whole city, then zooming all the way back down and recognizing the front door with a softer eye. The building hasn't changed. Your relationship to it has. Now feel the bed again. The weight of your limbs, the way the mattress pushes back. In purely physical terms, you and the bed and the planet are exchanging forces. Your mass tugging on Earth, Earth tugging harder on you. At the same time, in the small bright theater of your awareness, that pressure becomes I am being held up. The same gravity that keeps planets in orbit is what makes lying down feel like a safe, downward pull into rest. Biologists might describe your current state as a nervous system, shifting from fight or flight toward rest and digest. Heart rate ticking down, breathing deepening, muscles unclenching. Measurable things, pulse, hormone levels, patterns in brain waves. But from the inside, it feels simpler. You are allowed, for a little while, not to be in charge of anything beyond your own next breath. All the large-scale structures can continue without your supervision. If you let your attention drift toward tomorrow, you'll notice that your mind instinctively zooms back into the human scale. Messages to send, tasks to start, people to face. None of those exist yet. They are shadows cast backward from a future that hasn't arrived. The galaxies don't care whether you answer everything on time. Even Earth doesn't. The pressure comes from inside your own small circle of meaning, and that means it can be eased from inside too. One way people ease it is by ritual. It might be as simple as brushing teeth, dimming lights, putting the phone face down, and listening to something like this. To an outside observer, these are trivial actions, a few watts of power-changing state. To your nervous system, they're signals. The day is closing. The watch can be passed to background processes. Without knowing any cosmology, your body already understands that it cannot live at full alert all the time. Imagine your life, not as a line that must reach some enormous, impressive point, but as a series of nights like this, linked together, moments where you allowed yourself to be small and safe on a small world. In between odd, yes, you work, had, strive, love, fail, try again. But the string of evenings where you came back to yourself, remembered the larger frame, and let your shoulders drop, those are part of your story too, even if no one else ever reads that chapter. From the universe's perspective, your resting heartbeat, your slow breathing, your half-forgotten dreams are just local fluctuations in energy and matter. From your perspective, they are how you survive, how you reset between the louder scenes. The same physics that permits supernovae also permits sleep. The same grid of space-time that stretches galaxies apart also quietly holds a bed in place under a tired body. Scale doesn't care which you pay attention to, you get to choose. As your eyes grow heavier, you can let your sense of size shrink back down, like a camera slowly zooming from the cosmic web to a single lamp-lit window at night. Behind that window is you, in your particular room, on your particular piece of Earth's surface. You know now how small that window is in the grand scheme of things. You also know that it's the only place where your life actually happens. Soon, this whole grand tour can fade into the background, like a mural on the inside of your skull. Always there if you want to glance at it, but not demanding constant attention. In the foreground, there will just be breath, weight, warmth, maybe the faint sounds of your environment. The universe can keep being vast and ancient and complicated outside. Inside, it can become very simple. A tiny temporary mind, on a tiny temporary world, allowed for tonight to rest. In the final stretch of this journey, we won't need any more zooming, or numbers, or distant structures. We'll just walk a slow circle around this one small fact you've earned, that Earth becomes almost invisible at the true scales of the universe, and yet, for you, it is more than enough. From there, the only thing left will be gratitude, a bit of quiet, and the gentle permission to fall asleep while a small planet carries you through the dark. You've walked a long, quiet arc tonight. You started in a single room on a familiar planet, then watched that planet become a globe, a small world in a family of worlds, a dot beside a star. You saw the solar system turn into a tiny clockwork inside a galaxy, then that galaxy sink into a web of countless others. By the time you reached the edge of what light can show, Earth had vanished from every honest map you tried to hold in your mind. Along the way, you learned why your inner pictures have always struggled. Diagrams have to lie to be legible. Posters compress distances, inflate planets, brighten faint things until the ratios collapse. Even scientists, with all their instruments and equations, work with mosaics of partial truths. One graph for size, another for brightness, another for time. True scale is so extreme that any drawing that's completely faithful would look like almost nothing, with your entire world too small to mark at all. And yet, even as Earth kept shrinking on those outer maps, something else quietly stayed the same. The feeling of lying in this bed, on this piece of floor, under this patch of ceiling. No matter how far you zoomed out, you never stopped being a small body held by gravity, wrapped in air, listening to a story. The galaxies didn't yank you away. They just rearranged in the background while your breathing rose and fell in the foreground. You've let the timeline stretch too, back through Earth's long alien histories and forward to its distant futures. You saw how most of the planet's life has unfolded without you or anyone like you, and how most of its future will do the same. In that light, your lifetime is a scratch on the last page of a very thick book. But scratches can still be real, and the fact that they're short doesn't mean they have to be shallow. Somewhere in this journey, the question, "Do I matter?" shifted shape. Measured in light years and billions of years, the answer is simple. You're almost invisible. But measured in experience, in what it actually feels like to be here, the picture changes. On that axis, your life fills the sky. Your joys, worries, and small acts of kindness are not footnotes to galaxies. They're the entire content of the universe as far as you can directly feel it. We've also stopped for a moment with the people who built your cosmic address, the observers timing moonlight with lasers, the engineers who sent Voyager to take a last look back, the teams who mapped the cosmic microwave background's faint freckles. All of them tiny, all of them briefly awake on this same small world, reaching outward with equations and mirrors so that someone like you could lie here years later and hold a truer, gentler picture of where you are. If you're still awake now, you might notice that the ache of smallness has softened into something closer to tenderness. Earth really is tiny at the true scales of the universe. Your life really is brief and narrow. And yet within that narrowness, you get to exist at all. To breathe, to think, to listen, to rest on a warm planet that is, for the moment, still alive and orbiting quietly in an ordinary arm of an ordinary galaxy. Before this fades into sleep, if you feel like leaving a little trace on this pale dot, you can let me know in the comments where on Earth you're listening from and what time it is there. It's strangely comforting to imagine these small pockets of awareness scattered across the planet, at different hours of the night, sharing the same slow story. And if you want more nights like this, more science told softly, at this pace, you can always tap like or subscribe so you can find your way back. Soon, none of this will need to stay sharp in your memory. The numbers can blur, the diagrams can fade. What matters is the feeling you carry forward, that it's okay to be small here, that you're allowed to rest on a world that barely shows up on cosmic charts, that the universe can remain vast and unsolved while you set your burdens down for a while. The big machinery will keep running without your supervision. For now, that's enough. Outside, Earth turned silently through space, its thin film of air holding oceans, clouds, cities, and a few scattered people falling asleep. Inside this one small room, your body grows heavier, your breath steadier, your thoughts slower and softer. Somewhere between one heartbeat and the next, you can let go and let this tiny planet carry you unnoticed through the dark. One more small light briefly lit in a universe that is finally quiet enough tonight for you to rest.